us today. Right. Talking about DriSteem controls, we'll kind of cover what are the different control platforms, how we apply the controls, what are the different things we connect to them, and how to do some of that from a wire diagram portion. Hopefully raising up that understanding of DriSteem controls from a 2.8 to maybe 3.5. I don't know. All depends on, hopefully you're getting something out of this. So with that, let's get started. So my name is David Baird. I'm a senior applications engineer here at DriSteem. And so I get involved with a lot of applications questions, and controls sometimes is one of those questions, or even on the back end that our technical support team will, how do I wire things up, making sure things are working properly. So controls sometimes can seem like a black box. How does this thing work? And so we'll kind of delve into that a little bit, but more so on how do I connect to it, how the specific products operate. I'm not planning on covering that, but just making sure I understand what are the options, how do we utilize them, and how do I connect to them. So with that, let's get going. So if you have a question, feel free to use the chat function, and you can do that. Otherwise, you can raise your hand, which we'll address at the end. If you use the chat, either myself or one of the other helpers can potentially address that during the presentation. But feel free to utilize those options so that way you can get your question answered. Otherwise, we'll allow you to be able to ask that question directly at the end if you would like. So with that, what are the different controllers that DriSteem utilizes? 9 times out of 10, it's going to be Vapor Logic. This is the main one that we utilize. There are a few others, but the next primary one that we'll see is the one for just the XTR, and it has a reduced set of functionality. The CRUV has a few other controllers, but not nearly as common. So if these are the two main ones, how do they compare? Well, what's really helpful is the XT kind of gives us an idea. The XTP uses Vapor Logic. The XTR uses that other controller, and be able to look at some of the additional functionality. Some of the things that stand off right off the bat is just the interface a little bit different. Vapor Logic will have a nice keypad display letting you know more information versus just some indicator lights. You have interoperability options with Vapor Logic. You do not with the XTR controller. You can't do firmware updates. You can't grab information off of the XTR. It's, again, different functionality, a more sophisticated controller for Vapor Logic. And then you've also got Ethernet connection as well. So there's a more feature-rich option for Vapor Logic than there is for XTR. But they both accomplish boiling water, setting humidification to where you need to, which is what you need at the end of the day. And we'll kind of compare some of those different options and how to connect to them. We'll use this kind of back and forth. So with that, okay, Vapor Logic, as I said, 9 times out of 10, that's the one that you're going to be. Whether it's a steam generator, a steam dispersion panel, a high pressure atomization system, or an RO system, it's used in all. And consists of a microprocessor board and a display. Now, because it's used on a wide variety of products, obviously there's different portions that are being used. And that's where a configuration string is used to know, hey, I am a gas humidifier versus a water treatment system. Operate a little bit differently, but the same control platform is utilized, which makes it nice and easy. I'm used to what it is. The connections are similar, and the interface as well. Some of the other things for Vapor Logic said, okay, the connections, the board layout's the same. Where we connect some different devices will vary. And that config string is the key piece. That way, as I said, gas humidifier versus a water treatment system versus a high pressure atomization system, they all will operate a little bit differently, and that's managed within the code. But all the interoperability connections for sensors, very similar. And right now we're on Vapor Logic 6, which is red. We had previous iterations at different colors, trying to make it easy to identify if you need support. Knowing the color of the board will help to make sure that you're getting the right information. In terms of the displays, this is where there's a little bit of difference. It's the same main board, that same red board, but some of the legacy products utilize the keypad display, the XT, Vapor Mist, VaporStream, STS as an example. Some of the newer products, such as the RTS and GTS, they're on the touchscreen display. And you'll see the functionality is similar, just the amount of information, how you interact with it is just a little bit different. But again, still connects to that main board. One of the other things that VaporLogic, you have an option is if you're not near that display, you can check it on the web. Utilizing the web interface just basically gives you an even larger version of the display. Yes, you can see some stuff. We can see far more even if you were to connect into it using the web interface as well. Same functionality, just bigger, essentially. Requires to be on the same network as it. So once we kind of have that understanding, let's talk about control theory a little bit. And one of the things I like to think of is who's in control as to what the humidifier needs to do. Obviously, we're trying to meet a humidification set point. Well, are we giving it some information? The reading in the space is 30%. I wanted 40%. So I just take the sensor reading, and the set point then resides within the VaporLogic controller. In that case, it's controlled by DriSteem. I know what the reading is. I know where I want to be. This is what I need to do to get there. And it determines how hard the humidifier needs to operate in order to achieve that goal. If it's controlled by others, think of this maybe as an external demand signal or a humidistat. It knows the reading and it's telling the humidifier what needs to happen in order to satisfy that need. Think of it as your thermostat at home. I walk up to it. I want to raise the temperature. I just press the button. It resides at that local device and not back at the main controller on VaporLogic. Now, there's different functionality that you can get, more sophistication when more things are considered from VaporLogic and that control by DriSteem. There's not a right or wrong way to do this, but understanding where is kind of the brains for where am I at versus where I want to be. Is it residing at the local device on VaporLogic, or is it happening at that external device, such as a humidistat or a demand signal coming from others? So with that, okay, then if you're using sensors, what type of sensors are we using? More often than not, we're thinking of things from a relative humidity. I want to be 30% relative humidity or 40%. Okay, I know what that is. And one thing to kind of keep in mind is temperature is one of those key pieces. If you're trying to control the RH, having a stable temperature is important because a 1 degree temperature change is about a 2 to 3% RH change. So if you can't control temperature tightly, you're not going to control your relative humidity tightly either. Yeah, if you're in more of a critical application, this is where maybe I want to control an absolute moisture content, not a relative portion, but an absolute. And that's where dew point can be helpful. It takes the temperature out of the equation. Regardless, I want this total amount of moisture, period. The relative portion may change based on my temperature. So for a critical application, this may be a better choice. But most of the time, we see people utilizing relative humidity control. So where do you put these pieces? Well, most of the time we think of putting them in the space. We're trying to control the space to make sure it's at the target we want. And putting it in the space is helpful because, hey, I get a good idea. It's right where I want to be. Now, you have to be careful where I put it in the space. If it's on an outside wall, okay, maybe that's going to have a little temperature difference than it is the middle of the space. If it's sitting right next to somebody and they're breathing on it, guess what? Their moisture will influence that reading. If the sunlight's shining on that device, oh, again, the temperature will change, therefore the relative humidity will change as well. So trying to have a good representation of the space is important. Stay away from a few of those pieces. Sometimes we think of it as if we can avoid some of those concerns of being on an outside wall, the sunlight shining on it, as an example. Putting it in the return air is a great spot because I don't have to deal with some of those local things that are in the space. Get a good representation of what's happening. I just happen to do it on the leading side instead of directly in the space. So that may be the preferred spot, and that's kind of where you see a sensor one. Hey, put it in the return so you don't have to deal with any of those localized aspects that directly in the space. Otherwise, putting it in the space is just fine. You're trying to see Am I at the moisture content I'm looking for? And that way you know you've achieved your goal. The other way to do it is discharge air control. And I would say that this is used less often. It is a little bit harder to control. When you're in a space, you have all this dampening effect. I'm adding the moisture. I see what's happening entirely to the space. In discharge, you're seeing the moisture go across the sensor once. That's it. So it can get into more of a hunting. It's trying to meet that requirement, but you're not controlling directly what's in this space. Sometimes you have no choice. If I'm trying to control more than one space, if it's an air handler serving more than one floor, I want to know the moisture content. In this case, this is where that absolute moisture content from that dew point is probably the better route to go. I know the amount of moisture. Now the relative may change because each space is different, but I can establish a baseline and meet that target. So that's, if you're considering discharge air control, I've always suggested people looking at an absolute or a dew point to compensate for that. Sometimes it's just application. Putting it in the space, you know that space is satisfied. I can read what the space is. You don't know exactly what's happening in the space if you use discharge air control. So in order to connect these, and that's from a vapor logic standpoint, hey, it can use those external demand signals. And you can see, hey, a 0 to 10 signal, a 4 to 20 milliamp signal. Now, the vapor logic controller can take all these inputs. You'll need to tell it which type you're using so it can respond accordingly. Or if you're using a transmitter, again, hey, in this case, DriSteem it knows the set point, it knows what the reading is, takes that, again, connecting into it. Again, need to let the controller know, which can be done through the menus. Am I working off dew point or relative humidity? It needs to know what type of signal it's working with to make sure it can respond accordingly. The XTR, similar type of thing. It's going to use only, though, you're not going to, because there's not the interface to, hey, I want my relative humidity higher or lower, it's just going to take a signal from others. Is that controlled by DriSteem? Isn't a choice when we get into the XTR. It's going to get that demand signal from a humidistat or an analog device. In this case, instead of using the menu to tell you what type, there are different dip switch settings that have to be done. So something just a little bit different type of controller. That controlled by DriSteem. In order to be able to do that, it's vapor logic. Controlled by others, either controller system. But we also want to consider safety. So we want to make sure that we're putting in the correct amount of moisture. We don't want to add too much moisture, which is where a high limit humidistat can come into play. We know we want in this space, but maybe the temperature in the ductwork is cooler. We don't want to reach saturation, potentially causing wetting in the ductwork. That sounds like a bad idea. So we want to control what that is. And so that safety device is one we always recommend. There's two different ways to do it. The first of which is an on-off high limit. Think of it as coming up to a stop sign. I reach that mark, I stop, and that's it. Waits till I'm allowed to go, which means that the relative humidity is dropped. Then it can start up again until it comes to the next stop sign. The modulating high limit, think of it more like a yield. I'm getting close to it, start slowing down so I can get as close as possible without overshooting. So that modulating high limit gives a little finer tune control, gets as close as it can without going over because it starts throttling back the output accordingly. Again, that's going to be something that the modulating high limit, that's going to need vapor logic. It needs to know what the reading is and respond to it, which is where vapor logic comes into play. If you're working with anything other than vapor logic, it's simply an on-off. I've reached that set point, which is done at that local controller, and I've stopped until it is okay to run again. I would say most of the time, people use that modulating high limit. I'd rather get as close to that target as I can without overshooting versus just stopping. And in terms of that high limit, one of the things you'll look at is, I want to suggest, hey, put it 8 to 12 feet downstream of where you're heading that dispersion. Now, sometimes that's not always practical. You don't have that amount. Try and get it as far downstream so that way the moisture has a chance to mix with the air as possible, but before a transition, because that's what you're concerned with. You don't want wet turning beans or the next component downstream. So try and get as far as you can. and you want to give it time to mix. Granted, if you've got a lot more contact points between the steam and the air, it'll mix faster. Space them further apart, it's going to take longer. You want to give it time to get a good reading. The other piece that we're concerned with from a safety standpoint is if there's no airflow, we're adding this moisture and there's nothing for it to interact with. So we want to make sure that there's air moving across the dispersion device. So this is the other safety device. This one, put it upstream, downstream, doesn't much matter. You're just looking for, is there airflow to add the moisture to that we're looking for? If there's not, let's not add it, as otherwise the steam will, as an example, if we're talking steam humidifier, will end up just staying in that spot, potentially coming in contact with the perimeter and condensing. We don't want that to happen. And similar to what we have with the high limit, two different ways to achieve it. Most of the time, people use that pressure switch. I know that there's airflow. I don't care how much airflow there is, and it's just a pressure setting. Hey, I can prove that there is. As long as I'm above that mark, we're good to go. Sail switch is less common, but this sometimes, basically think of it as kite that makes in the airstream. You have to have enough velocity to be able to cause that kite to come up, and it knows, hey, there's airflow. The challenge you run into there, though, is if you're moving too fast, well, that kite's not strong enough to handle high velocities. So you potentially have to make that smaller. That pressure switch doesn't care. It knows I'm above that reading, I have airflow. The sail switch is less common. You need to have a minimum of 250 feet per minute, but in higher velocities, you may have to trim the size of it. So honestly, I'd kind of go with the pressure switch. I know there's airflow. I don't care how much. That's the better way. I don't have to worry about my kite essentially ripping off. So to connect those, these are going to connect in a different spot for vapor logic. That way the controller can know, hey, I have airflow. Yep, it's in that spot. I can take that reading directly. Connects in the same spot, whether it's the pressure switch or the sail switch. And a separate then connection for the ductile limit. Again, it knows the reading. That way it can respond to that accordingly. For the XTR, all the safeties are done in series. It's an on-off device. Remember, we're getting a control signal by others. There's a requirement for moisture. And, oh, there's no airflow, therefore the signal doesn't even make it to the controller. Or the high limit is set too high, it doesn't allow it to run. So different type of arrangement. That XTR or that non-vapor logic just knows I'm not allowed to go. I don't know why. Maybe the space is satisfied or the safeties are not satisfied. Vapor logic, I can know individually what is happening with each one to know, oops, did a sensor fail? I can diagnose that because I know what is causing the humidifier not to run. One of the other things that comes into play, and think of this more in cold climates, is if we add too much moisture to a space, we potentially get condensation on the windows. I think of it as my son's room. When he's sick, I put a humidifier in his room. Well, if I run it too much, I start to get foggy on the windows, which meant I probably overdid it, even though he may feel better in the morning. In order to prevent that from happening, we can do a window condensation sensor, basically a sensor in the perimeter to know what the dew point is, so we can not overshoot what it is and respond. So this is another control device besides our safeties and then our control signal. And just, you've got the relative humidity sensor, then a temperature probe that sits on that perimeter, as an example. The way this gets wired, this is where vapor logic comes into play. Again, all of that full functionality, that if the control by DriSteem, we're taking the reading in the space, we can respond to this and therefore adjust the output. Again, try and think of it like that modulating high limit. Try and get as close as possible without overshooting. You can do the same thing with the temperature compensation. If it's being told what to do from the humidistat or something else, you can know what it is, but you can't respond because you're being told from that control by others what the humidifier needs to do. So you're aware of it, but you can't act unless that control by is by DriSteem. We're taking a reading, determining what needs to happen. something that can be helpful, at least in cold climates, as an example. Other things, other capabilities. So sometimes there's times where you want the humidifier to run or not be able to run based on an additional circumstance. And so the master enable is a common way I've suggested people to do it. Regardless of what the space RH is versus what the set point is, I only want you to run when this happens. If that's the case, using a master enable circuit is one way to be able to do it. Whatever that condition is, basically a dry contact. When that is met, then the humidifier is allowed to run. It looks at all of the control signals, input safeties, and then operates. And if you don't want to use it, then I believe it comes already with the jumper there, so it's ignored. If you want to utilize this functionality, you pull the jumper out and can take advantage of it. Again, this is one of those Vapor Logic options. Another piece that comes into play is, hey, maybe you want to know I'm broke. Well, you can either find out that the moisture is not where you want it to be, or by walking up to the display. But what if you had an indicator like, hey, I'm broke, alerting somebody, pay attention to me? Well, maybe you could do that with a relay. Basically, if there's a fault, energize a dry contact circuit, turning the light on. Hey, red, I'm broke. This can be helpful. That's one example of where a programmable relay may be used. Or maybe you want to trigger some other action. Typically, the humidifier is humidifying. I want to know that's the case with a dry contact, or there's a fault. There's a number of different ways that that can be used. And there's two of them that can, again, the contact ratings are there, but that can be really helpful depending upon what you're trying to do. So 2 relays, choose which one, set what functionality you want to be able to do that. But I would say probably the alarms is probably the most common. I'm broke, alert somebody. That way they can pay attention. Now the XTR does have something similar, that simpler controller. You can't choose what it is. It just says, hey, I'm broke. There's an alarm, similar type of concept. So you can't trigger what is going to happen to it. But again, you've got a normally open or normally closed contact that you can use in that same type of functionality. Interoperability. This is part of the reason why we've moved to the Vapor Logic. We want to monitor what's happening on the humidifier. Whether this is Modbus, BACnet, MSTP, or IP, or LAN talk. LAN talk requires additional hardware in order to be able to do it. And I think that's kind of being phased out, that functionality exists. And allows you to kind of know what is happening with the humidifier in part of a smart network. You can even control input. I want to change what the relative humidity set point is, and as an example, it can be done through interoperability. So it gets a lot more types of things. Now, the amount of stuff you can do with it is daunting. There's a lot of set points. This is just an example of a few of them. And the variables are there, whether it's Modbus or BACnet or LAN talk, what those control variables are, and whether you can read them, whether you can write them. And there's pages and pages of them in the Vapor Logic IOM. Keep in mind that Vapor Logic is used on all those different types of equipment, whether it's a water treatment system, steam generator, high pressure atomization system. So there's a lot more data points. Sometimes it requires a little bit of filtering to know which ones pertain to the specific unit I am applying it to. But there's a wealth of information there to kind of see what information do I want to extract as to what's going on. So I would encourage you to take a look at that IOM, grab the relevant points that you're looking for. Hey, is the humidifier operating? What mode is it in? Is there a fault? Is it draining? You can find out all these different things and through it. Understand exactly how the equipment's working. So, other ways, if you're not using interoperability to monitor what's happening, the keypad. This is really the main way you're going to interact with the unit to know what is going on. The main page gives you probably the most common information. Hey, I'm running. Am I full of water? Gives me some basic information. We use a lot of submenus to kind of navigate through it. Hey, what's happening from alarms? I can get to that messages. up and down arrows, standard on the standard keypad. Now, the home screen for the touchscreen, you'll notice there's more information that you can get at. In this case, instead of having to push buttons, I'm just interacting directly with the touchscreen. Gets a little bit more information, a little cleaner display as an option. You can kind of see what the home screen looks like for the keypad on the left and the touchscreen on the right. A lot more information, more intuitive. Allows you to kind of know, hey, what's the water level? Is there a problem going on? Am I working? So the navigation for the keypad, it's kind of using those up and down arrows, pushing enter to navigate to each one of them. Granted, there's only so much content you can see at a time, but you've got status, diagnostic, alarms, and setup. Setup, hey, I decided to change to a modulating high limit versus this on-off high limit. You're going to do that through settings. You can change that. You don't have to change the config string and call the factory. You can change those settings on your own, as an example. Status, this is going to give you a lot more information as to what the humidifier is doing. What's the demand? What's the output? Do I have enough water level in it? You can find out a lot of that information. I will say one of the most common things is that mode is probably one of those common questions that our tech support team gets. If the mode is not in auto, then the unit is not allowed to operate, even if there's a demand. If it's in standby, it means it's sitting there idle, waiting until somebody enables it, which is where the auto mode comes into play. So keep in mind, if you want that humidifier to operate for the season, put in auto mode, then it's going to start triggering, responding to whatever control inputs are going on, and is allowed to operate. If it's in standby, it's disabled, kind of like that master enable. Diagnostics, this can be really helpful. One of the things you can do with Vapor Logic is pull data off of it, which we'll talk about in a moment, but grab information about it, what is happening. If you're getting into troubleshooting, this can be really helpful in coordinating with our tech support team. Some of the other things, this is where that there's a USB port. You can do updates for firmware. You can grab data off of it, so both way communication. Or, hey, grab the configuration. I said everyone is programmed for a specific application. That way, this is a gas humidifier. Well, I can grab that configuration. So if for some reason I have a problem with it and I need to change it, using that saved, I can plug it back in and it knows what I am. And it has all the settings we did already. Another helpful piece from diagnostic standpoint is to kind of the test mode. Test mode allows you to kind of run everything, or I can test specific pieces. Let's energize the fill valve, make sure I can hear the click and it's working. Energize the drain valve, grab an individual component, or allow the unit to run regardless of demand signal for a period of time to just check and make sure everything is good to go on it. Basically, this simulates demand for a period of time. After it's done, it's going to move back to standby mode. I mentioned earlier, standby mode means it's going to sit there idle until it's enabled in that auto mode. So something to kind of keep in mind, if you use that test run, flip it back to auto later, so that way it's allowed to run when it needs to. The alarms, there's different types of alarms. Some alarms will be, hey, it's going to shut the unit down, not allow it to run until there's human intervention. There's other ones that will try and clear and correct it. And those on the touchscreen, sometimes they're kind of red, like it is critical. It's going to stop it. You may have an informative message, which is going to be in a white, or something else preventing it potentially from a yellow kind of self-clearing. So on the touchscreen, it's a little easier to kind of know how urgent is that message or alarm. The red means I probably need to act on it. Whites, it's helpful to kind of understand, but a history of alarms is available on either one of them to kind of know when did a fault happen, what was it, and there's a date and time stamp according with it. Setup, this is where I said, hey, I decided to change from a modulating high limit to an on-off high limit, or vice versa, or I've changed from a relative humidity sensor to a dew point sensor. I can do that all through the setup. set the input type so it knows what I'm responding to. If a change happens to it, this can be helpful to kind of grab that. To set up what is the communication protocol for interoperability, as an example. All of those things. Mini drain mode is another thing that can be changed and set up. That's an option for the RTS and GTS. Multi-tank is a concept that VaporLogic has. You may have a really large humidification load that you just cannot achieve with one steam generator. You need more than one of them to achieve it. The concept here is that you can use multiple together to achieve that one really large load. The way multi-tank set up is there is one display controlling the array of humidifiers, essentially. And all the controls connect into one, communicating with all the other humidifiers to work as a whole cohesive system. So this is one way, instead of having to connect up all the sensors to every single one of them, I can do it as a multi-tank arrangement. In this type of concept, you've got that one display. I check and see what's happening with this one, and I then change to one of the other humidifiers to see what is happening on each one of them. So keep in mind, one display, and I can change which one I'm looking at as part of this whole system. So you'll have a primary. That's the one where all the controls go to. That's the one that's going to have the keypad. The secondary humidifiers, these are the other ones that are supporting to achieve this goal. And it communicates with the primary. So a communication piece is key, so that way I can communicate information back and forth. The other thing that comes into play is just because you've got multiple humidifiers, how do I intend to run them is a question mark. And we use priority groups as a way to kind of accomplish that. The lower the number, the sooner it is allowed to operate. So a trim tank, as an example, which has a priority of 0, is allowed to run first, before any of them that are in a 1, 2, or 3. So if you have more than one humidifier as part of a group, if they're all number 1s, as an example, they will bounce back and forth in terms of wear leveling. If there's one that has a lower number, it will act first, and then a higher number will come on, which is why that redundant is intended. It's never going to run unless some of the others are broken. The highest priority group for it. Now, XT humidifiers, they don't have, even though they've got VaporLogic, they cannot utilize multi-tank. That's accomplished in a different means, which we call staging. It still allows to achieve similar functionality, but instead, you bring all of the sensors into the primary tank, even though we don't call it that, and we send the information on to the next humidifier, as an example. In this case, it's a staged concept. So you've got your primary connecting all your sensors. The next ones are staged. We jumper out the safeties in the other ones. You don't have to do in that multi-tank arrangement. And then you're going to want to set when is the first one will operate over a 0 to 10 volt range, as an example. The next one's allowed to run once I reach 5 volts, 50%, and it will operate in that higher portion of the range. If you don't change that, they're both going to operate at the same time simultaneously. If you want them to be staged, one comes on first, and then the next one, then just change when it is allowed to start. This is one way to kind of achieve that for an XT or electrode type humidifier. Again, we don't want more than 2 cylinders connected to a system, but this is one way to accomplish that. But what about pressurized steam systems? They just have no controller. It's basically a valve that you're connecting up. Well, you still have to control the valve. You want to modulate. It's not an on-off device. In this case, you still want to have those safeties, airflow and high limit, no different. Maybe you've got a temperature switch to make sure that, yes, there is steam there. It's not full of condensate. That's covering the power side going into the steam valve. Then you've got the controller sending in what is the amount of demand required. Think of this as that humidistat because, again, there's no VaporLogic. It's demand by others. So this is a way to kind of be able to accomplish that for a pressurized steam, a steam injection type unit, or an ultrasorb connected up to a boiler, as an example. But sometimes I think of my home, and if I have a TV that's older, I don't have all that functionality like connect to the internet, making it smart, right? Well, we can use a backnet humidistat to kind of bridge, similar to what a Roku might do as an example. In this case, we could apply a backnet humidistat to one of those controllers that doesn't have vapor logic, that's already got that interoperability, or to that pressurized steam system. And now I can monitor what's going on a little bit. Granted, it's only whatever inputs are coming in. So this can be helpful in the backnet humidistat. I can connect off the high limit to one spot, the airflow to another, and I know, hey, I'm not allowed to run because of the high limit or because of airflow. I can take what the reading is, so I can get more information what's going on to kind of bridge that smart concept, that interoperability to know what's going on. So this is one tool that can be helpful to kind of add a little bit more information into a building automation system, as an example. Now, there's a lot more resources. I know we kind of skimmed a bit of things, but all the wiring diagrams for any one of the products is available on the website. And you can visit the product pages if you're wondering what are the connections for a GTS, as an example. You can go to the GTS and find out everything you need to know about it, including outdoor enclosures. And then you can also get all the information you need for vapor logic, talking about all the different settings you can do, all those different protocols and objects that you can do for interoperability is available there. So these are a lot of the primary resources that I've used looking through controls. Each of the products will discuss how the unit operates specifically, but the controller is universal. So with that, are there any questions? Feel free to kind of use that chat function. We'll look at that. Otherwise, we'll enable you to talk if you want by raising your hand, and you can speak your question as well. It's like there's one question. So it's like there's a question on the input resistance 500 ohms. Okay, so the humidity transmitter. Trying to read it quick. So if DriSteem supplying the humidity transmitter or modulating high limit, then this is not concerned, which is correct. So that input resistance that we're looking at beforehand, back here. This is where the wiring gets a little bit specific. I'm not sure which slide per se, but okay. So then there was another question here about the dispersion tube upstream of the cooling coil. Now the placement, okay, like that. Sorry, trying to find my slides quick. The placement as to where the dispersion goes, this is something that's kind of covered in terms of the placement. What I would say is the placement really kind of depends on what you're trying to achieve. You want to have it downstream of your heating device. That way you have warmer air. Moisture will absorb easier the warmer the air is. Putting it before or after the cooling coil is variable depending upon what you're trying to achieve. So that's there. Okay, there is going to be a recording for if you did register for that. You can look at the recording.
David, I just want to note that Kevin did unmute, so he can ask his question more specifically.
Sure.
Hey, David, can you hear me?
Yes, we can hear you.
Hey, it's Kevin Phillips from HTS. Just that was my question there. It was about that input resistance. If you can just go back to your overall page that shows all the possible vapor logic control devices. That's where the note was.
Okay. Yeah, and that 500 ohm resistor, that's basically used to try and take that 0 to 10 volt signal with the 500 ohm resistor to get it into the correct reading is what it's there for.
Correct, but if we're doing transmitter by DriSteem, whether it be the that's not a concern then. That's just if somebody else is supplying that they make sure they meet that resistance. Is that correct way of?
That is correct. Yeah, so
Okay.
there's no additional device needed if you're using one of our standard transmitters, whether it's dew point or RH.
Okay, thanks, Dave.
Yep. So what that looks like. Kind of trending and logging capabilities the Vapor Logic controller have. The Vapor Logic controller will monitor what is happening with it. I believe we do every 30 seconds by default, and it's like 2,000 or so data points. I think it's about 2 weeks roughly, or 1 week worth of time, depending upon how many spots those are of operational data. When you do that download, you can grab that. So the faster you're recording, you'll fill up that queue sooner, and then kind of keep incrementing, losing the oldest information. So that is something that can be helpful, especially when you're getting to troubleshooting. What is happening, to know everything that's happening, the state of the fill valve, the drain valve, the contactor, the input signal, airflow, high limit, all of that can be really helpful when we're getting to a diagnostics mode, or why is my humidification system not working as it's intended.
And then Veronica had her hand raised. I'm not sure if it's the same question, but if you want to unmute Veronica, you're welcome to.
Yeah, it is. I had a few different questions. So this comes up quite a bit when my contractors go to install. They're like, this humidity transmitter and the high limit humidistat, isn't that the same thing? There's always some confusion. And then the question that follows is, does it what is the generator going to control to? Is it going to be to the humidity transmitter, or is it going to be the high limit humidistat? Like, they hear stat and they think like that's what's dictating things. So how would you dumb it down to communicate it to?
Okay, no, great question. To answer your first question, the modulating high limit and the humidity transmitter are exactly the same device. It's a matter of where I connect them to and what we do with that information. So wherever we connect up to this, like we're looking at here on this screen, where we're putting that RH into P11, that is going to be used for demand purposes. That is the reading that it's going to try and achieve. So that one there, not the modulating high limit, that's the one it's trying to achieve that set point period. They'll take the reading, what the setting is, or the target that's in the controller. The modulating high limit is connecting to a different spot. Modulating high limit's connecting into a different spot, and that is being used as a throttle mechanism, basically, is what's happening. And so it's still trying to achieve what is connected to that primary. I want to achieve that target, and the modulating high limit is used to throttle the output if it's going to get near saturation or whatever that high limit set point is. So there's two different settings. One is, okay, what is the condition I'm trying to achieve, 40% relative humidity, and then there's a separate setting for what is the maximum amount of relative humidity I want in the ductwork, as an example. Whether that's done at the high limit humidistat, which is a dial, or I put it in the controller, don't allow me to go above 80% relative humidity. So that's different spots, different settings to be able to kind of use for it. But I can understand the confusion when it's the exact same device being used for two different purposes.
So it's quite literally the exact same device. So they'll receive.
It is literally the exact same device. Exactly.
They'll receive two of these, humidistats. One's intended to go into the duct. One's intended to go in the space as a safety to make sure we don't. It's okay. All right. Yeah. That makes.
So if you're using, obviously the modulating high limit's always going to be a duct device. The relative humidity one for control purposes may be in that return airstream, like we're talking about for sensor one, or it may be a room type device. So that way you can tell that they're different. So
the high limit.
Good question,
is
and I can understand the confusion.
Duct. Got it. Okay.
Yeah.
And then also, so a lot of the times we'll submit on these. We'll submit with control by vapor or control by DriSteem, right? And after that, it gets on site, whatever. We have controls contractors is like, no, we want controls by us. Is that as simple as like they provide their own stuff, they do their own, they provide the signal, like they don't use, the DriSteam supplied humidistats and whatnot. Like, do I just send them, to these wiring diagrams where it's like, okay, fine, you want to do, by others, then here you go.
And I would say there's two pieces to it. One of which is to have the correct wiring connections. The other is, we talked about changing the sensor reading. Is it a dew point versus an RH? That's also done in the program to let VaporLogic know its demand by others. So there's two pieces of software to make sure it's configured for an external demand signal that controlled by others versus by DriSteem, and then where I connect the device. So make sure you've got both pieces. We'll set it up based on what's ordered. If it was ordered controlled by DriSteem, it's going to be initially set with that. It can be changed in the settings, be controlled by others instead.
Great, thank you.
But yeah. In terms of service training, we don't have much service training available online. A few videos I think out on YouTube that kind of talk through maintenance of equipment. And I believe some of the controls is covered on that with our VaporLogic, but we do have additional training that's available from a contractor standpoint. We typically offer in the spring as well. So that addresses that question. Are there any other questions? Well, if not, thank you very much for attending. And hopefully, Danielle, you were maybe going to do the slide at the end, kind of raise up. Hey, did you move from that 2.8 to something higher? Maybe you did. If not, that's okay. We'll kind of use that feedback and get additional training or collateral available. But your questions, I think, are hopeful, helpful, and maybe you moved your level up. Feel free to kind of use that survey. And thank you for your time today.
Thank you.
Thank you all for attending. And like David mentioned, there's a quick poll. Just give yourself a 1 through 5 rating after the webinar is completed, just telling us how comfortable you feel. After you answer that question, you can go ahead and log off. Thank you all for attending, and have a great day.